So this slide has the rules, the names for how we name organic compounds. This unit has a fair bit of memorized. It's very different than a lot of the other chemical units or chemistry units, which is a lot of calculate, solve. Okay? You just straight up have to memorize a lot of naming rules. This is like learning a new language. So the IUPAC rule for any organic compound that is 1 carbon long, you're going to see meth used as a prefix. Okay? The stem refers to the longest chain. Okay? And in the examples I've done so far on the previous slide, there was only 1 chain. Okay? Things will get more complicated as we work our way through the unit, and you'll have a long chain, and then you'll have a branch coming off of it. We're going to have to name the longest chain. We're going to have to name the branch. When you have a branch or side chain that is 1 carbon long, we use that same meth, but we just put a YL after it. So you're not memorizing 2 things. You're memorizing meth as the longest chain, methyl if it's a branch. Okay. 2 carbons long, F. And if you have a branch, 2 carbon longs, ethyl. Okay. These are words you're going to have heard in modern culture. Unfortunately, one place that these show up a lot on TV is in drug names. You're going to hear all those names coming up right now. 3 carbons long, prop. Okay. And if it's a branch, propyl. 4 is not but, it's bute and butyl. Now, if you're good at your grade 3-4 polygons, you're going to rock the rest of these. Okay. So what is a 5-sided shape? Pentagon. Okay. If you have 5 carbons, it's pent and pentyl. And now we're just running through prefixes that you've heard of before. Might be rusty. Hex. Probably the most challenging is hept to remember. Students are pretty good at stop signs or octagons, octal, oct, or octal if it's a branch, and non and dec. And that's as far as you have to know for this course. Or pretty much any course that you'd be doing, even as an undergraduate student. As always, if I scroll too far, just let me know. So just before I move on and we start going through examples, and then we're going to learn by families, by organic molecules that have similar properties and similar shapes. What do I mean by stem and what do I mean by alkyl? So for this first example, or only example on this slide, I'm going to do 4 carbons in a line, but then I'm going to put a branch off one of them. We have a carbon that is connected to 3 other carbons. So this is our Y, or what I mean by a branch. Okay. Now, I'm not going to write in all the other H's. This is not a proper structure, but I find it's clearer for students when I leave all those little H's out. Okay. So I've put the dash, I just haven't put an H at the end of all of those dashes. Okay. And again, I'm doing that for clarity. Okay. It'd be wrong if I was, trying to draw a structure. I left out the H's. The longest branch, 1, 2, 3, 4, 1, 2, 3, 4. No matter which way I go through that branch, the longest stem is 4. It doesn't have to be right to left, and I guarantee you your diploma, and I'm going to try to trick you by making the longest chain up or down, or maybe the longest chain will be a C shape. So look for that longest chain. The longest one we call the stem. Okay. This is a personal strategy. I always make a snake, or kind of a, I'll just call it a snake, around the longest stem, which may zig and zag. So I have all 4 of those carbons in my stem. So that means the stem is a but 4. Okay. I have 1 carbon. This carbon is part of my stem. This one is not, and there's 1 and no more. So this, when we go to name it, math 1 carbon, YL because it's a branch. So that's how we're going to get the pieces. I haven't told you how to put them together yet, but we need but for the 4, we need methyl for the branch, and what's coming next is what you use to tell the reader that these are all single bonds. That's really the last missing piece, and then I have the whole thing put together. And we're going to dive into the ane family, which is when there is all single bonds. So our first family, and this is how the next probably 3 days is going to go. I'm going to do a family, go through it, examples, maybe talk with physical properties, and move on to another family. So alkanes. These are organic compounds that contain carbon and hydrogen only. The first criteria. Second, all the carbon atoms must be connected with single bonds in order for it to be an alkane. And these are probably our simplest organic compounds, and these would be the backbone of the Alberta oil industry. These are the simplest organic compounds that are going to be formed and come out of the ground. So what I've done is I've pre-constructed a proper structural diagram that you would have done in Chem 20. If I asked you to draw a structural diagram, you need to show all the bonds, all the H's. Okay? If you're wondering why it zigs and zags, the software I used takes VSEPR theory and bond angles in deciding how to make the shape. When you're assessed in this course, you don't have to have the right bond angles. You don't even know when you start. So do not worry about VSEPR. It's good to know as a student, but you don't get assessed on that. But so you know, that 109.5 bond angle for something that's tetrahedral is what you're seeing here. And you'll see it in textbooks a lot. You'll see it in examples. And if you're just wondering why, that's the reason. So I want to name this alkane. It's C and H only and all single bonds. We know it's a member of the alkane family. If I start here and draw my snake, I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yeah, I was right. 7 carbons, and I never reached any branches. So there are no alkyl groups or branches to worry about. So who's got a good, without flipping back in your notes, what stem name is this? Hep. Okay. And then to tell the reader that there's only single bonds between those 7 carbons, we add A and E, which is coming from the name of the family. So that is heptane. We're going to do a second example of a branch. I'm just making sure everybody has the first example done. Is everyone okay if I scroll down? So you'll see there's 7 carbons again from right to left, but the second carbon over has a carbon coming off of it. Okay. You can draw this in a straight line if you like. It's faster often to draw it in a straight line, and that's totally acceptable within Chemistry 30. So first thing you need to do is always find the longest chain to name an organic compound. Now I've got a branch here to watch out for. If I start here and go left to right, 1, 2, 3, 4, 5, 6, 7. Now I have to make sure I don't need to sort of make a non-linear shape. 1, 2, 3, 4, 5, 6, 7. Even if I go the other way through the branch, I still get 7. It's not any longer. When it's a tie, it doesn't matter which way you go. You'll get the same name either way. Okay? So we have a tie. So I'm going to pick one of the 7 long stems. Now the H's don't matter in our naming, so don't worry whether your snake goes around the H's or doesn't. Try to visually ignore those in coming up with the name. Okay. This carbon is inside my stem. I've got a branch. When I box up my branch, there is just 1 carbon. Okay. Now, the snake and the boxes are a personal strategy. They're not something you have to do, but I do it consistently throughout this course. I make a snake to the longest chain. I do a box around my side groups. So now we've got all the pieces to name this. The stem is where we want to start with. That's 7, so it's hept. All single bonds throughout the stem, so it's an heptane. Okay. Now I've got to tell the reader about that side group. That's 1 carbon long, meth, side group YL, so I have to add that in. Side groups go in front of the stem. So methylheptane, I left a little space there. It shouldn't be there. It's 1 continuous word. I'm not too picky on the spacing because you're not writing these names often from the start back. You're writing this, and then you're going in front. Okay? But there are no spaces. Okay? Now, does that name perfectly convey that structure and that structure alone? We've got a methyl attached to a heptane. But yeah, it does really matter where this is. We need to convey to the reader, where do you find this methyl? Okay? If there's more than 1 possibility, you have to put a number to tell the reader. Okay? Now this methyl can't be at the very end, because then it would be part of the longest chain, and this would become an octane. So the 1 position isn't allowed. Okay? It wouldn't be a heptane anymore, but it could be in the second, off the 2nd carbon, or it could be off the 3rd, or potentially off the 4th. Okay? Now the naming convention for organic molecules is count from the end. That would be the shortest way to get to it. Okay, so I'm not allowed to start naming here. IUPAC says that's incorrect. 1, 2, 3, 4, 5, 6. 6 methyl heptane, incorrect. You didn't minimize the number. To minimize the number, you need to start from this side. Now, I like to put a star on my notes for the side I'm counting from. Okay? For a student, it tells me you know what side to count from, and as a teacher, it reminds students. Particularly, you're looking at my notes online, and you're like, what's that star for? That's where I counted from. Okay. Slowly, I'm going to throw more groups at you: oxygen, chlorine, fluorine, single bonds, double bond, triple bonds. You might have to name a whole bunch of stuff. You have to stay on the same side through the whole question. So this is my first carbon. That's my second carbon. The methyl is coming off the second carbon. 2 dash. Anytime you transition from letters to numbers or numbers to letters, you have to put a dash. I don't put a dash on this side because there's no letters in front of it. So I'm finally finished. This molecule is 2-methylheptane. One more example on a third slide, and then I'm going to go through the rules that I'm going to follow to name these, and then we'll keep building up on our complexity. Is everyone okay? Now this drawing is a slightly condensed structure. Okay. And in a future lesson, or maybe later today, I'll go through some of the condensed structures a little bit more. All I've done is pull all the H's into the C's instead of doing 3 lines out. Okay. So we're not in a structural diagram anymore, we're in a condensed structure. I think it's clearer. It's a nicer teaching tool because I don't have all these H's all over the place cluttering my diagram. And our goal here is to name this. What do we call this structure? Okay. Everyone on the planet is going to follow the same set of rules. Okay. And these are just scientists, IUPAC, making up the rules that we're all going to follow. We don't have to like the rules. This isn't some scientific concept. It's rule making. Okay. And the first main rule is find the longest chain. Okay. And you're going to, again, watch for that on test. We're going to try to trick you to make sure you really understand this. 1, 2, 3, 4, 5 if I go that way. 1, 2, 3, 4, 5 if I go that way. 1, 2, 3, 4, 5 if I go that way. It's a 3-way tie on no matter which way I go. Okay. So it doesn't matter. I can go up, middle, or down. Okay. Dylan, which way would you like me to go? Down, he says. Okay, so he made the decision. It doesn't matter. Would all get the same name. I'm not going to do it all 3 ways, but if you don't believe me at home tonight, go the other ways and you'll find out you get the exact same name. So we have a 1, 2, 3, 4, 5 carbons. So we have a pent, all single bonds. Pentane is our stem in our family. Now I have to look for the alkyl groups. Here I have a carbon, and here I have a carbon. So you might be wondering, is this 2 methyls, or is this 1 ethyl? So we need to sort of start outside, start at our group, and head back towards our chain. And I can't count this carbon. This one's already counted, so I have to end my box right there. Those 2 branches are not directly connected to each other. Okay? They're not 1 branch, they're 2. Okay? If you box them up and you don't go through that carbon, you will clearly see how many boxes you have. Okay? And those are separate. Those are 2 methyls. Okay? An ethyl would be a carbon here and then another carbon continuing off the same branch. Now, it would kind of make for some really bad names. It would make it really long if I went methyl-methylpentane. Okay, but it just sounds redundant. So IUPAC doesn't do that. They use prefixes. They're going to call this a dimethyl because there's 2 methyls. Again, the branches go in front. And because there's 2 branches, we're going to need 2 numbers. Where's the first branch? Where's the second? So I need to count the shortest way to get to each of the branches. So pretty clearly visually, it's not going to be that side. I'm not even going to count. Visually, hopefully you can just see, it's definitely going to be this side. If I do this one first, this is the first carbon in the stem, that's the second. So this branch comes off the second. I'm going to put a number, a comma, and then I'll put the number to the other branch. This branch, 1, 2, it also happens to be coming off the same carbon. Doesn't have to. You can have methyls that aren't coming off the same carbon, and we'll see that in a bit. I have finished the name. This is 2,2-dimethylpentane. It's a pentane of 2 methyls, both coming off the second carbon. Anything that has 2 methyls coming off the second carbon that's 5 carbons long is this structure. Okay. My smartboard wouldn't let me do it right now, but you could rotate this, flip it in any orientation, and it's still, if the second one over has 2 methyls, it's this name. Now at this point, I want to start going through what rules I'm following. I think most of my students learn by watching me teach, but by sort of inspection, but some students want the rules. Okay? So I'm trying to cover my bases both ways. You like rules, here they are, and I'm going to keep doing examples, and you can just keep watching me go through examples. Okay? Now this is going to work for all families. Okay? So you've seen a little bit of these rules, naming anes, enes, ines, and then we'll use them for more families too. First thing that I've been doing, find the longest chain. Okay? And get the right stem. Okay? Then you're going to add an ending. If there's single bonds, as you've seen so far, we use the ane ending. Okay? If there's a double bond, you're going to use ene as your ending. And if there's a triple bond, you're going to use ine. Pronounce the Y like an I. Now, luckily, there's no pronunciation test in this course. You're going to write a lot of names and be thankful you don't have to speak them out loud. Now, the rule 1A talks about putting a number in for the family. When you have single bonds, you don't need a number to say where the single bonds are. They're all single bonds. Numbers would be a waste of time. But if you have a double or a triple bond, you need a number to tell the reader which bond, and I use my words carefully, not which carbon, but which carbon-carbon bond has the double bond or has the triple. So we're going to have to count bonds and put a number in to tell the reader where it is. So I have a 4 carbon long example that I'll do to illustrate the 1A rule. All the carbons are in a row. There's no branches, so our stem is going to be a bute. I notice a double bond, so this is now an ene instead of an ane. And I left a gap because we have to tell the reader where is that double bond located. Okay. We now have to count carbon-carbon bonds going from the shortest end, okay, which is pretty clearly going to be on the left for this particular example. Now I'm going to number my carbon-carbon bonds. I'm not numbering carbons, I'm numbering the bonds. This is my first carbon-to-carbon bond, that would be my second, and that would be my third. So that double is the very first carbon-to-carbon bond. So this is a but-1-ene. You always do this step first. Even if there was a branch, you're going to ignore the branch. You're going to set your star and your numbering as the shortest path to the double bond. Okay. Then you get in, we didn't even get to the branch rules. Okay. So if you get confused, you're doing homework, you got a branch and a double bond, which one should I deal with first? Deal with the double bond first. Get your star down. That's always going to be where you're going to number from. So all the rules on the next slide deal with all the branching scenarios. And we've done a few of these. Name the side chains.
So it's an introduction to grade 10 students, last name N, O, and P. Please make your way to the gymnasium for your pictures. Please enter on the side doors in front of the woodshop lab. That's grade 10, N, O, and P. Thank you.
So you're going to determine all the side chains. Those I like to put boxes around. That's just a personal strategy. And their positions. Okay. So figure out all their numbers. Okay. And we've done examples with one branch and one number. You've also seen an example of this second branching bullet. If there's two of the same alkyl groups, you use a prefix in front of that alkyl group. Di, tri, tetra. For di, you need two numbers. If you had 3 methyls, I'd be looking for 3 numbers, a position for all 3 of them. Is that okay? Is that okay? I'll put it on D2L. Can you just leave a little space in your notes? Is that okay? We just have one more main. What if you have multiple alkyl groups? So if you have more than one type, and I'm referring to alkyl group, we're going to put them in alphabetical order, and then you've got to put all of those pieces together. So an example of what that would look like, this name has 2 ethyls, or this molecule has 2 ethyls and 1 methyl. So there's 2 different types. Okay, we have the ethyl and we have the methyl branches. And I threw in, there happens to be more than one ethyl. Ethyl starts with an E, methyl starts with an M, so I put the ethyl part first and the methyl part second. The reason again I put in the dye is the dye doesn't affect. The fact that there's 2 ethyls is irrelevant. Just go to the E and the M and get the order. Do you have a question?
Please, teachers, ignore that bell.
You just put them all in alphabetical order. You'll probably only ever see 2 is probably the most that you'll see in questions that you'll get. Okay. And you'll see examples of me doing this. Last bit, very rare. Your diploma almost never puts this on tests. I'd like to put it on a quiz to make sure you understand it. Check to see if any of the should be numbers. If any of the numbers are not necessary. If a number is not required, it's dropped. Now, when I say not necessary, it means because there's only one option. So maybe you have a molecule like this. Two carbons, F, double bond, ene, but there's only one spot the double bond could be. We don't need a number. We don't need to say F1-ene, because of course it's an F1-ene. You can't have an F2-ene or a 3-ene. If there's only one possible number, you don't write it. So this is F-ene. F1-ene is not correct. It has an unnecessary number in it. Okay. Now the number doesn't have to be a 1. If the only possible number was a 2, then you wouldn't write the 2. Okay. So it's something to watch out for. Again, the diploma tends not to assess this. I like to push APs a little bit to make their brains work and look for this. So you might see it on a quiz, you'll see it in homework. You're definitely going to see it, but probably not on your diploma. But it could be. It is the proper way to name things. Last bit, those prefixes if there's more than one alkyl group. Okay. So you saw me use di already, and I mentioned tri and tetra, but I want them in the notes.